Okay, guys. Okay, guys. We are now starting on something that is not in the book. Okay? It is in the book, but it is not labeled and consolidated, rather. It's not consolidated the way I'm consolidating this today. And today we're going to be talking about the library of functions. The library of functions. These are pretty much the basic functions that we have already worked with for the most part. And if we haven't worked with them yet, we will soon before the year ends. And I also added some that you're going to see next year and also in Algebra 2. Well, in pre-calculus for you guys. So I'm going to go rather fast with most of these. I know that a lot of you, I can see, did not have your PDFs printed out. You're going to have to watch this at home tonight because I'm not going to wait for you. First of all, let's look at the general forms of the parent functions of the library of functions. These are the parent functions. Remember that the parent functions are the functions when you have nothing but x being squared or cubed. You have no shifts, no translations. My first one is an identity function. Identity function, just so you know, is also called a linear function. And it's f of x equals x or x equals y. If you want to know how did he get these points, make an x and y table. You connected the dots and you have a straight line. That's a linear equation. It's also called an identity function. Just so you do know, there's something called a constant function. Constant function. And the constant function, I gotta just teach to you, is an f of x equals a function. So for example, y equals 2. Y equals 2 goes this way. That's a constant function. It's called constant because there is no slope. The slope is 0. So therefore, it's constantly going to give you a y value of 2. The next one, they call it a square function here, but guys, it's a quadratic. And we know that. We've been working with this. Again, how did we get these points? I make an x and y table. This is the parent function of a y equals x squared. This is a U-shaped graph. Done. This is a cubic function. This is f of x or y equals x cubed. How did I get these points? I make a table of values, an x and y, and I choose x values of 1, 0, and negative 1. For this particular case, please pay attention. It's a little curvy thing, little curvy guy here, little curvy guy. All right. We have to memorize these because we're going to translate them and transform them today. So we have to memorize them. Okay, now, reciprocal. Reciprocal function is also known as a rational. Remember? Because we already solved rational functions where x is the denominator. And in a rational function here, for this one, they choose one value to the right of the y-axis and one value to the left of the x-axis. 0 in this case cannot be possible because I cannot have a 0 in the denominator. So for the reciprocal function, my friends, just choose, if you were going to make a table, just choose x as 1 and y as 1. And you're going to see you're going to get 1.11 and 1 point here, negative 1, 1. You have to learn the rhythm of a rational. It approaches the y-axis and it approaches the x-axis, but it never gets there. On the third quadrant, it approaches the y-axis and approaches the x-axis, but it never gets there. I'm not looking for Picasso, okay? I'm not looking for Picasso. I'm just looking for you to give me a general sketch of that. You definitely have to have the exact 1 point, but then I'm not going to accept this. No, that's ridiculous. But if you did this and it was a little bit closer, yeah, that's fine. I accept that. I know that you know what you're talking about. Okay? Square root function. We have solved square roots. We've worked with square roots. We haven't graphed them yet. A square root function, if you can see, it's only on the right side of the graph, to the right side of the y-axis, because I cannot have negative values inside of a radical. At least I cannot have real values of y with negative x's. I can have a negative x inside of the radical, and of course that would just be an imaginary number. So for this table you use 0, 1, and 4. When you do that, you get these points for the parent, and it's basically half a parabola but sideways. The cube root, we have not worked with it. I just don't want you to see this on the SAT or the ACT and not know what the heck to do with it. You can make a table with this one with 0, 1, and negative 1 as x values because you have a cube root. Or remember, you can't have negatives inside of a cube root. So the points here you find by using a table. Now, the cube root is different than the cubic. The cubic is kind of a squiggly S going up. This is kind of a squiggly S going sideways. Okay? Sure. Okay, the question was, could the square root function go down? Yes, if it was negative. Remember we talked about reflections and how you flip them? We're going to talk about that in more detail today. But yes, if it was blue, that would be a reflection, and that would be going negative. It could be both at the same time if I have y squared equals x. And we'll get into that soon enough. Thank you, sir. Very good question, son. Okay. So, next. 1 over x squared is the same as a rational function, except when it's 1 over x squared, know this. You're going to have approaching the x and y axis on the left side, and then approaching the x and y axis on the right side as well. You're not going to have it in opposite quadrants when it's y equals 1 over x squared. I'm not going to stress too much about this one. I'm not even going to stress about the exponential or the logarithmic. In fact, I'm going to ignore it right now. When we get to it, I will expect you to have these notes and know what they look like. But right now, I'm ignoring the exponential. Looks cool. You can look at it. Look at what it looks like. I'm ignoring the natural logs. I'm ignoring the sine and the cosine. All of this you will get to, but not yet. Why am I giving it to you now? Some teachers don't prepare this for you. So I just want to make sure you have a good solid set of notes when you leave here. This is tangent, cosecant, and secant, and cotangent. Don't worry about this. I promise, not yet. Okay, this will be next year and also junior year. But the ones that we want to do, stop. You stop at exponential and logarithm. Now, let's talk about transformations. All right, we already talked about transformations of parabolas. Quadratics, so we're going to start with that again, a little review. To help us better understand transformations of graphs, we will look at the following transformations for f of x equals x squared. We're going to look at vertical shifts. Remember, vertical shifts belong to the k, up or down. Horizontal shifts, remember, horizontal shifts belong to the h. Remember that it's the opposite, guys. Remember, if I have x minus h, that means you go to the right. Remember, the h is opposite. And then a compression or an expansion, compression or expansion, you're dealing with the A. Remember, you're dealing with the A. And then a reflection, you're either multiplying the whole thing by negative or you're multiplying the x by a negative. We're dealing with negatives. So let's look at all of this really, really quickly because we've already done this. You guys know how to read. You have a parent graph, y equals x squared. I'm doing a vertical shift, so I add 3 to both. I add 3. So every single point goes up 3, goes up 3, goes up 3. We went over this last week, so that's why I'm flying through this. If I have y equals x squared minus 4, that means I'm shifting everything down 4, down 4, down 4. Okay? When you're going to do this, please remember, you can have different colors if you want, or just graph the parent function in dashes. And then do the real function, the shifted function, in solid lines, please. Horizontal shift. Okay, this time you're attaching it to the x, guys. Please pay attention. It's inside of the parentheses. Okay, inside of the parentheses. So if I have x minus 2 inside of parentheses squared, it's opposite. So I'm shifting everything to the right, 2 points to the right, everything to the right. If I have x plus 4, it's opposite, so I'm shifting it to the left, to the left, to the left. Always graph your parent and then do your shift. Combining shifts. You can combine shifts and have, for example here, x plus 3 squared minus 5. Okay? Now, if they give it to you in vertex form like this, this is pretty sick. Okay? You don't really need to shift anything here. Don't you know your vertex is -3, -5? Ah, you see? And then now if you wanted to, find a y-intercept. Make x 0, that's 3. 3 squared is 9. 9 minus 5 is 4. So 1, 2, 3, 4. Could have just gone there. Then here's your mirror image. You got 1, 2, 3 to the left. You go 1, 2, 3 to the right. And then that would be your graph as well. So you could have done it that way. We have that skill. But let's say you don't want to do it that way. Cool. Graph your original graph. I'm going 3 to the left and 5 down. So I went 3 to the left, which that's why you went this way, and then 5 down. That's why you end up here. You with me, my friends? Okay, compression and expansion. Again, all of this is review. Compression and expansion. Okay, when x, I'm sorry, not x. I don't like, if the number being multiplied to x, okay, I don't like that. Let's make this an A, and let's make that an A, all right? Basically what's happening here, guys, when A is greater than 0, that's this example here, okay, the original one is in black, that's this guy, and then the y equals 2x squared is in blue. So just like we said last time, when you have A that's greater than 0, you're talking about a vertical stretch. You're vertically stretching it, so it's becoming thinner. If my A is greater than 0 but less than 1, okay, and I'm sorry, this should be absolute value. Absolute value. If it is greater than 0 and less than 1, then I'm going to widen out. This is my original. Now I have y equals 1/3 x squared. I widen it out. So what happens there is when the absolute value of A is between 0 and 1, it is a horizontal compression. And then I'll give you another example here. The absolute value thing, that's what they have here by saying, note that I'm ignoring the negative numbers so far. Yeah, I don't want to worry about if they're negative or not. Negative is just going to make it go up or down. We're going to look into reflections now in a second. When we're looking at compressions, it's the absolute value. Okay? Absolute value of A is greater than 1, then the graph is, well, you see, they compressed it, but that's horizontally. Okay, this is a vertical stretch. This guy right here, when the A is larger than 0. When the absolute value of A is between 1 and 0, it is a vertical compression. So remember, vertical stretch is the same thing as horizontal compression. Vertical compression is the same thing as a horizontal stretch. Remember that they're reversed. They're the same thing. Okay, our reflection. Okay, we had some questions on this last week, so that's why I wanted to make sure you guys understood this. Okay, when you're multiplying a negative in the front of an equation, okay, the graph flips over the x-axis. Basically, what happens when you multiply the whole entire value of y by a negative, you flip over the x-axis. That's why you have y equals x squared is pointing up, y equals negative x squared is pointing down. I multiplied the whole entire function y equals x squared by a negative. So I got y equals negative x squared. Negative's on the outside. It's in the front. Okay, it goes down. It reflects over the x-axis. Now, look at what happens here in this particular case. If I wanted to reflect this over the x-axis, it'd be negative on the outside, square root of x, and it'd be down there. But what did I do in this case? That is not what I did. In this case, I multiplied the x, only the x by a negative. When I multiply only the x by a negative, my friends, I'm going to go ahead and reflect over the y-axis. So that's what reflecting does. Okay? Makes it turn upside down, or if it's pointing to the left, it goes to the right, or to the right, it goes to the left, vice versa. Does that make sense? Okay. Now, I wanted to give you guys the function of libraries, including the transformations. Because a lot of times people understand the transformation, but they don't know how to put it all together. So for absolute value, it's A, which is, remember, the compression or the stretch, times the absolute value of x minus h, that's your horizontal shift, plus k. Quadratic, A times parentheses x minus h squared plus k. Cubic, A times x minus h cubed plus k. Square root, A times square root of x minus h plus k outside of the square root. Cube root, A times the cube root of x minus h, close the radical sign, plus k on the outside, and reciprocal or rational function 1 over, actually, oh, I screwed up. I'm sorry. There should be an A here. Let me fix that right now. Please fix it on your PDFs. Oh. Okay. Thank you, son. And there you is. Wait. Oh, what am I doing here? There we go. Still not. There we go. Okay, yeah. No. Oh, I'm going to have to do it one more time. Jeez. There we go. Okay. Sorry. Okay. So there you is. Awesome. Okay. Thank you, guys. Now, let's graph these right quick. Let's graph these right quick. Okay, because this is really simple. All right, what's going to happen here for number 1? For number 1, we'll do it in black. Okay, what's my vertex?
2, 4.
2, 4. So go 2, 1, 2, 3, 4. And then what's my y-intercept? Here's my axis. That's going to be, 8. So that's here. 2 to the left, 2 to the right. You're done. Now, you could have also done this, guys. You could have done the parent function, which is y equals x squared, which hopefully by now you've memorized 0, 0, 1, 1, negative 1, 1, and dashed it. And then every single one of these points, 2 to the right up 4, 2 to the right up 4. Huh? What? Oh, sorry. Thank you. 0, 0, 1, 1, negative 1, 1. Okay, so 1. Two to the right. Oh, yeah, it's going to be here. That's why. And then 2 to the right, it'll be there. Okay? So you could do it either way. I find the vertex way a lot easier. Okay, let's look at number 2 now. Number 2, we'll do it in red. First of all, it's a square root function. So you got to remember that in a square root function, it's y equals square root of x. So that's 0, 0, 1, 1, and 4, 2. That is my parent function. What am I doing with that parent function? First of all, I am reflecting it. I'm reflecting it. And then is it going to be thinner or wider? Or? Okay, I'm doing a horizontal stretch, so it's going to be going up higher. And then, where do I go? How do I shift it?
Go to the left, down 3.
3 to the left?
3 to the left, down.
And down 1. So 0, 0 is going to be that again. So I go 3 to the left, 1, 2, 3, down. Hold on. No. So I go 1, 2, 3 to the left, down 1. That's my new one. Down 1, 2, 3 to the left, down 1. That's my new one. Down 1, 2, 3 to the left, down 1. That's my new one. Oh, wait a second. But it has to be reciprocated. Hold on. I screwed up. Okay. Whenever you have a negative, guys, this will make your life easier. Instead of graphing the positive parent, graph the negative parent. Let me just pause. So, when it's negative, guys, I suggest the following. Graph the negative parent. Okay? Graph the negative parent. So what am I talking about? The negative parent here would be negative square root of x, correct?
Yes.
Okay, just negative square root of x. So, actually, you know what? You have the negative 2 here, right? So make your life even easier. Go ahead and graph that parent like that. Go ahead and graph it with, make a table with the a. So just remember, you got 0, 1, and negative. No, you can't have negative 1. So let's do positive 4. So when it's 0, we got 0. When it's 1, it's negative 2. When it's 4, it's 2 times negative 2, so it'll be negative 4. So we have from our parent 0, 0, 1, negative 2, and 4, negative 4. See how it's a lot wider? Okay, but from this, didn't I have to shift every point 3 to the left and 1 down? Okay, so that's my little parent, but now I gotta go 3 to the left and 1 down. 1, 2, 3 to the left, 1 down. 1, 2, 3 to the left, 1 down. 1, 2, 3 to the left, 1 down. Yeah, it's gonna be a lot easier. So whenever you have a complicated situation here with a negative, regardless of what function it is, make that part of your parent. Graph those parent points and then shift left, right, up, and down. Does that make sense? Okay. For this next one, okay, well, y equals the absolute value of negative x plus 2 plus 3. Okay, this is going to be an absolute value equation. Absolute value equation, if you do the parent for that one, it's 0, 1, negative 1. It's 0, 0, 1, 1, 1, negative 1, and it's a V shape. But I'm going to be shifting, aha, look at this, I forgot this. There's a negative here. Okay, let's talk about that. Can't I factor that negative out? So I have a negative on the outside, so I have x minus 2 now, plus 3. So now my parent would be y equals negative absolute value of x. So that's going to be 0, 0, 1, negative 1, negative 1, negative 1. That's my parent. Now, how do I shift it? 2 to the left and 3 up. So 1 to the left, 1, 2, 3. 1 to the left of 1, 2, 3. 1 to the left of 1, 2, 3. That's my new graph. Does that make sense as far as transformations go? Yes? Okay, let us continue. Quadratic inequalities. Don't worry, it's not hard. Quadratic inequalities are graphed using the same skills used to graph quadratic equations. The only difference is as follows. When dealing with greater than or less than, use a dashed line, guys. When dealing with greater than or equal to or less than or equal to, okay, use a solid line. So when using greater than or less than, use a dashed line. When using greater than or equal to or less than or equal to, use a solid line. Everything else is the same, and then you got to shade appropriately. For example, let's go ahead and graph what I got here. Number 1. Sometimes they'll give it to you in vertex form, sometimes they won't, guys. So you have to know your procedures. Number 1, let's find our axis. Our axis is negative b, so in this case, over 2a. So x equals 1 is my axis. So I'm going to make my axis a symmetry. Done. My vertex. My vertex is going to be 1, comma, so that's 1 squared is 1, minus 2 minus 3, so it's minus 5 plus 1, negative 4. So 1, negative 4. 1, 2, 3, negative 4. My y-intercept is negative 3. That's one to the left of the axis, one to the right of the axis. Now, is this going to be a solid or a dashed? Solid. So I'm going to go solid because it's greater than or equal to. Now here is the part you just got to think about. Whenever you're talking about if it's greater than or less than or equal to or greater, how do we shade? Shade from the vertex. I promise you. Guys, what values are larger than the vertex? Above this or below it? Above it. So you shade everything up here. You're done. If it was less than or equal to, then it would be everything out here. Does that make sense? Promise? Okay, last thing. I know you want to get out of here. Last thing, I promise. Let's knock this out real quick. First thing I'm going to do right off the bat, so I'm going to divide by negative 1 to make this positive. So I got x squared plus 5x plus 6 is now less than or equal to 0. Why did I flip that? Whenever I divide by a negative, okay? Now in this case, okay, this is going to be a little bit ugly. A little bit ugly. However, can't I factor this? So this is x plus 2 and x plus 3, right? So we know already that my solutions are negative 2. You with me? And negative 3, right? It's going to be a really thin little graph. Okay? This is going to be a nasty axis of symmetry. It's going to be x equals negative b over 2a. So negative 2.5. I'm not going to make you do that here, but this is what I will do. Negative 2.5 is in here somewhere, right? I know you guys want to leave. So plug in the negative 2.5 in here. Find the value of y, which I'm going to make up a value. Let's just say it was right here. Okay? Pay attention, please. Originally, it was negative. But when I divided it by a negative, it became positive, and you have a completely different answer. So I'm going to graph this. And now this is, you always read from the 0 or the y, not the equation. So 0 is greater than or equal to x squared. It's greater than or equal to, so again, it's going to be shaded in here. I hope you guys enjoyed that. May God bless you. Thank you for a great lesson. Hasta la vista. Homework is valid.